Right, today we're going to learn combination gates. So what is combination gate? You have two or more gate connected together to produce results. Okay, to understand combination gates, you must obviously understand individual gates, something that we've done before. We've done XOR gate, OR gate, NOT gate, AND gate, NAND gate, and so on. So let's have a look at two different gates with something that we've done before. We'll look at OR gate. Okay, so and see what the OR gate does. So in an OR gate, if you have input A and B, so if you have input A as 0 and B as 0, the result it produces X as 0. And if A is 0 and B is 1, and if it goes through OR gate, the X becomes 1. If you have A as 1 and B as 0, then it will produce 1. If you have A as 1 and B as 1, and if it goes through OR gate, it will produce 1. So that's how an OR gate actually works. So let's look at NOT gate. So if you have A is 0, and if you go through the NOT gate, the opposite side, the other side, X will become 1. So if you have A is 1, then if you go through a NOT gate, then X will become 0. So these are the two gates we're going to use to combine them together and see what happens. So you have your OR gate and you have your NOT gate, they're connected together. So what happens? So this is what happens. You have an A and a B, and then he actually produces something in between called C. And then he goes through a NOT gate, and then after he's going through the NOT gate, you have your final result, okay? And the final result is X, okay? So we're going to look at this, and we're going to look at truth table and see what he produces. If A is 0, so A goes in, then you have B is 0, so B going into OR gate, and the results he produces, OR gate normally produces, is actually 0. A is 0, B is 0, therefore is actually the C would be 0. So C going in quickly and coming through straight through the NOT gate again. Now obviously if 0 goes in, the opposite of 0 is actually 1. So therefore X should produce 1. There you go, you got 1. Okay, so then the next one is if A is 0 and B is 1. So if A going in 0, B going in as 1, the OR gate should produce the answer for C is 1. So you can see 1 quickly going in and going into the NOT gate. Okay, and because 1 is going into NOT gate, we expect 0 to come out. So there you go, that's your 0. Then and let's look at another one. So you have A is 1 and B is 0. So A going in as 1, B is going in as 0. So the OR gate is actually producing 1 as a result for C. And then basically 1 going into a NOT gate, we expect the other side, X, to be 0. Okay. And finally A is 1 and B is 1. So 1 going in for A and 1 going in for B. And we expect the OR gate to produce 1 as an output and as a C. And 1 going into the OR gate and the other side, X should become the opposite, which is 0. So there you have your combination gates. So this is how you actually fill your truth table for your combination gate.